all wonder why the circumference of a circle is 2 times pi times r. No idea, right? But we all know that. That sounds like a fact. So how do we prove that? It's very simple. It's also about the application of the integration. And specifically it's about the concept of how we calculate the length of a curve that we just talked about last episode. Okay, so let's talk more about that. So why your circumference is 2 times pi times r. I prepared a picture already here. Okay, so first of all, we find the function of this circle, which you all already know will be your x squared plus y squared equals to r squared. So let's just write it more standard, which will be your y equals to the square root of r squared minus x squared. Okay, so we all know if we want to know the length of a curve, so then we now need to find its derivative. So your f of x derivative will be your 1 all over 2 times your square root of r squared minus x squared and times, don't forget the chain rule, so you need to times 2 times x, which will be x over your square root of r squared minus x squared. Okay, cool. So now we have the ingredients. So we will calculate its length. But before that, we all know the circumference is symmetrical. So you can divide it into uh, 4 parts. So let's assume this part is capital S. So your circumference will be 4 times S. And to write it in the integration form will be equals to 4 times the integration from 0 to r of 1 plus x all over square root of r squared minus x squared and square root with respect to x, which will be your 4 integration from 0 to r the square root of, okay, let's calculate a little bit. So here will be, oh sorry, I forgot, here is square. Okay, so here will be your r squared because your x squared cancel out. And then on the denominator will be your r squared minus your x squared with respect to x. So now we can withdraw r on the denominator and the denominator. So which will be your 4 times integration from 0 to r times, okay, let's write it down, make it more clear, divided r squared. Okay, so which will become like 1 and the 1 minus your x over r squared with respect to x. So we all know when we see this kind of function, then we will use the trigonometry substitution, right? Because you can assume sine theta equals to x all over r, which your dx will be your, okay, let's see, r times cosine theta. So which will be, so your original equations will be your four times integration from 0 to r times, okay, so now it will become cosine theta, and then times, like, oh no, so not times, I don't know what I'm talking about. So on the denominator will be your r cosine theta with respect to theta. Oh, sorry, here I forgot to write down with respect to theta. No wonder, kind of feel weird. So now you can cancel out cosine theta, which it will become 4 integration from 0 to r of r with respect to theta, which, oh, sorry, here you also need to substitute. Don't forget, I need to go back. So here is actually wrong. So let's take another layer here. So when you x equals to 0, so your sine theta equals to 0, which your theta will be 0. So when your x equals to r, so your sine theta will be equals to 1. So your theta will be pi all over 2. Okay, so here will be pi all over 2, and here will be 0, which will be 4r theta from 0 to pi all over 2, which will be, because 0 times anything will be 0, so you will only have 4 times r times pi all over 2, which you can cancel these to 2. So your circumference is 2 pi r. Okay, so this is the application of the integration. And when we want to calculate about a length of a curve, so this concept actually let us know 2 times pi times r is a circle's circumference. Okay, thank you.